Namaste, sir.
Namaste, namaste.
Namaste. Am I audible
Uh,
properly?
yes, you are audible
Thank you, sir.
and visible.
Thank you.
Okay, may we start?
Okay, sir. We'll start. If there are
Uh,
sufficient participants, sir, we will start. I
yes,
can see only two here.
we have
12.
to wait for them
Only
for
12 participants
2 minutes.
are there.
5 minutes we wait for them.
Sure, sir. Sure.
Uh, very good morning to the madam and very good morning to all the student participants. Now we must begin our session. It is 10:30 and there are 18 here and 8 on YouTube. So today is the lecture of Dr. Priti Srinivas Sajja. She is working in PG Department of Computer Science, SP University Vallabh Vidyanagar. And I have the privilege to listen to her once or twice in the course of time, and it was a very wonderful lecture that she gave. And at that time, we had decided, Parul Madam and I myself, that we will invite her. And today she is with us. Uh, Her biodata is very long, but I will refer to only books that she has written. Two books. One is The Essence of Systems Analysis and Design, a workbook approach, and another is with Akrekar R.A., Intelligent Techniques for Data Science. So these two books she has written. Then there are chapters in different books. For example, Deep Learning for Big Data Analytics and Personalized Neurofuzzy Expert System for Determination of Nutrient Requirements. And she has presented many papers, and here is classifying sequences of market profile using deep learning. So that is her paper. Uh, so I welcome on the behalf of the department and on behalf of student participants, Dr. Priti Srinivas Sajja. And Madam, now I hand over to you and you speak to our students. Thank you very much.
Thank you very much, sir, for the kind introduction. Let me share my screen. Hope my screen is visible to everyone.
Yes, ma'am.
Thank you very much. My introduction is already given by the sir. This is my contact address. In the end of the lecture, I will be again sharing my contact address. As sir has stated, my subjects are artificial intelligence and machine learning and software engineering. My research and my all publications are in the field of artificial intelligence only. Since we are the users and I belong to particularly computer science, we are working with information and communication technology since long. New generation is having a lot of opportunity to work with the different type of devices, starting with the mobile and the smart TV. And lot many devices would come, latest devices, and we are rather surrounded by the gadgets and electronic devices, particularly communication and information technology based devices. So it has become inevitable to know something about the devices. And as we are, most of you rather are appearing for NET examination and other examination, it is in our syllabus that we need to talk about the computers and should have basic introduction to the computer science. Before I start my discussion, let me at this outset, let me thank Honorable VC Sir of my Sardar Patel University, Professor Niranjan Sir, Head and Faculty Member of the English Department, Parul Madam, Dave Sir, and all the faculty members of the English Department, our own computer center, and all the participants from India for giving this opportunity. So I am really very glad to be here, having me here. Thank you very much in advance. And this is the plan for our lecture. We are introducing what is ICT, what is information and communication technology, how digital computer works. We have heard and we have been using the digital computers and etc. and based devices, but exactly how it is working. So in a you can say layman's language, I would be introducing. No technicalities would be there. Though I belong to computer science, but I will restrict myself to common knowledge which you should know and NET exam related knowledge which you should have. So we will see how computer is working, particularly digital computer. We will see what is language, what is packages, and the block diagram of computers, different type of memories, RAM, ROM, EEPROM, flash memories, and hard disk, and different type of input, output, and storage devices. I have 2 hours, together, we have 2 hours to discuss. So we will try to cover the unit number 8 as much as possible. We will see different type of software such as application software, system software, including the operating systems, and advanced machine learning and AI-based software. We will see how ChatGPT works, just introduction only. And computer networks, and nowadays internet has become very much popular. So internet, cyber security, and in the end, we will see what are the audio video formats and their file extensions. So this is our plan for today's lecture. Hope you are comfortable with this. You can hear me in a proper way, and my language is okay with you. If you want me to talk in a mixed language or Hindi, please let me know. Since all the participants are all over from India, I would like to speak in English. But if you want me to talk in Hindi or mixed language, let me know. So this is our NET syllabus for paper 1. And today exclusively we would be discussing information and communication technology. And as you know, the NET examination is conducted by the National Testing Agency, NTA, on behalf of UGC. And it is actually having 3 categories: PhD with GRF, and assistant professor, PhD only, and assistant professor, and then PhD program eligibility only. Now we will start with our unit number 8, information and communication technology. What is information? First, let us break this phrase, information and communication technology, and we will see what is information. Information is actually processed data. Then you would have a question in your mind, what is data? So data is nothing but the rough or raw observation from the domain of interest. Suppose you see calendar here and you see red color on this Sunday, you would be happy because what you see is the red color only, that is the data. But you process it and you know that yes, it is a red color in a calendar, means normal it is Sunday, and or otherwise a public holiday, and we need not have to work. We need not have to go to office, and there is a special calendar or special program on the Sunday, so we are happy. But the same red color you see at the traffic signals. When you are just passing by or you are driving your vehicle and you see red color, that red color again is a data, but you process with a different metadata, different, you can say, context, and you process in a different way. And you would be irritating. When I am just passing by, then only the signal has become red. And it's a matter of 1 or 2 minutes only, but it is very difficult for us and we get irritated sometimes. So that red color actually processed in a different way and you are having irritation. And unfortunately, if somebody met with accident on that roadside and you see red color blood, you get panic also. You get panic attack also. So same red color and how you process it, that red color is a data and how you process it makes the information. Further, this information can be synthesized, analyzed, further processed with different, joined with each other. That is a synthesis actually. And then you would get some sort of knowledge. And again, you can go on applying morals, principles, and etc. You would be having knowledge and then later on continue with that. Then you are having intelligence. So this is the way how this data pyramid works. Basically, whatever with all our, you can say, senses. Normally, we have 5 senses. We can touch, we can speak, we can taste, we can hear, we can see, listen. So these are the 5 senses. And sometimes we have 6 sense also. So we have 5 senses, 6 senses sometimes, and we take all those data and our brain process it. And we create sometimes information. Further, we create the knowledge, wisdom, and intelligence. And then not only we have to process that, we have to understand it, but based on that, we are taking decisions also, and we need to communicate it also. So this is actually information and communication technology in a layman's language. So information and communication technology, now onwards it will be called as ICT. So ICT covers all technical means to handle data and information and aid facilitate communication. ICT means information and communication technology, and to handle information and communication facilitation, we are using some technical means, some instruments, some methods, some type of, you can say, models and etc. This is ICT. Okay? So these are the ICT. This is the ICT definition, and some examples of ICT devices are mobile, computer, panel of a fuzzy washing machine, etc. Okay, your GPS system in car. So these are the examples of ICT. There are methods also, there are architectures and models also. There are technology also, IoT, cyber security, machine learning, the methods and technologies are also there. So this is information and communication technology, and this is the era of information and communication technology. Earlier, what happened? We had very big computers and we have small work. Our expectations are very small. Insignificant expectation. Please calculate this bank withdraw and deposit or percentage calculations or file moving and uploading and etc. Nowadays, computers are becoming smaller and smaller and our expectations are ever increasing. They never stop. So we have bigger and bigger expectations, greater and greater expectations, and computer becomes smaller and smaller. Now we are working in the era of knowledge rather. And I should say that whatever things we are using, whatever actions we are taking, suppose we are going for a pizza eating, we are going to purchase a biscuit in a mall, is from a superstore, or we are going to purchase a shirt, or we are taking admission in a course, or we are applying for a NET examination, we are using ICT. We are using computer, we are generating lot of data and we are leaving behind a digital trail. Lot of digital data we are leaving behind. So this digital data we should utilize in an intelligent way. Every move we take and every step we make, every move we make and every step we take, we are generating lot of data. And if we can utilize this data in an intelligent way, we would be having, you can say, greater advantages over the other business. Excuse me. સર મારું લેક્ચર ચાલી રહ્યું છે અત્યારે, એટલે વેઇટ કરવું પડશે આપણે. નીચે ઓફિસમાં મળી જશે. So I am having a lecture right now, and it is live telecast. Excuse me, sir. Please. I will contact you later. Sorry, sir. So we were talking about the information and communication technology and the current scenario. All the technical means, including methods and models and instruments and etc. We can create data, we can handle data, and we can aid a communication. So this is our first understanding what is information and communication technology. Now let us see what is computer. What is computer? Say cooker cooks, driver drives. So computer computes. What does it compute? So it computes data and instruction. And computer is like our, you can say, servant, mighty machine, and we are the master of the machine. Now, when we are having some machine, we are having some servant at our home or office, we would like to take work from the servant. But servants sometimes will not work, rather majority of the time, servant will not work themselves. So what we will do, we have to give them order. Now consider the scenario. I will say that I am the professor and head of the department and I will talk in English only. Okay? I will not talk or I will talk in French only. My servant will not understand this. So I have to talk in their language, my servant's language. Okay? I have many servants and their languages I have to use. Suppose I have a computer as my servant, the mighty machine as my slave, then I have to talk in machine's language. So to take work from computer, two things are mainly needed. First thing is we have to give them order. Number one. Number two, to those slaves, those machines, we need to talk in their language only. So we have to talk in zeros and one. You would be having another question, why zeros and one? So computer is an electronic device and you can see you are surrounded by so many switches. Wherever you are sitting, at least few switches you can see, and these switches are having on and off status. On means one, off means zero. Only two status are there. So binary or a digital language, bi-state language is very perfect to give order, and computer can easily understand this language. This is binary language because number system is in your course. So you have the binary language. You have to talk in binary language. So computer is your servant. You have to talk in his language and you have to give order to get work with the work from the computer. So it's a digital device. We talk in binary language, and what we will do, we give command in a binary language Suppose I would like to add 2 plus 2 and make it 4, okay, and store it somewhere. So 2 is in binary, again another 2 data, second data is in a binary, and then instruction how to add them, that steps are also there in a binary, and it has to take these instructions and data from me, and it has to remember this data, it has to remember the instructions, it process the data and accordingly output the data. So computers are actually having a program stored in it. If it is not machine learning, little bit learning paradigms and learning algorithms are always there. So mainly our digital computer works in a binary language, and we are having a stored data, stored program in it. And always, say always if I have to add, always if I have to do percentage calculation, etc. Every time I'm not giving logic to my computer, converting it to binary and etc. But we are having a higher level languages, higher level packages and etc. And computers, third party tools, say, and computers translate automatically our English-like languages into the binary languages and remembers the program. Okay, whenever Preeti madam asks for addition, this is the logic. Add program we have to run. Whenever we have to print a mark sheet with the result and grade and etc., then this is the program. Run result and print mark sheet. Then only it will take the data from the computer, take the data which we provide about the students and subjects marks and prints it. Computers are very good in some sort of, you can say, aspects, some aspects such as efficiency. Some sort of efficiency oriented parameters, computers are really very good. For example, computer can store data for a long time. Computer can process data in very fast manner. Suppose I have to calculate my income tax, I have to calculate my percentage from the mark sheet or from the subject's data, marks and etc. Then I am having lot of interest, and with the total, you can say interest and focus, total precision, high precision, I will be calculating my data, my result and my tax and etc. I want to calculate, I want to save my money, and I want to calculate and know my percentage. So it is my percentage, my money. I would be much more accurate and I am much more interested in it, and happily I would be calculating this. But suppose thousands of, you can say, such students' mark sheets are available and data available, and thousands of people, employees, pay slip, or you can say income tax, I would like to calculate. Then I get tired. I may not be that much accurate. I may not be that much faster like computer, and I will not remember the data which I have processed. Computer will remember. Say, how many of you remember the Boyle's law? The pressure, quantity, and volume are related with each other. Every day we see somewhere the gas cylinder, LPG, but we don't even remember the full form of LPG. We don't know what is the pressure, quantity, and volume. If you go on giving the pressures, if you go on increasing the pressure on the gas, it will become liquid, and the volume and the pressure and the quantity is related. These are related with each other. This is the Boyle's law. This we do not remember. We all have studied it in an 8th or 9th standard. Everybody, irrespective of the science stream or commerce streams and etc., we have learned this, but we will forget this because we are not using. Computer will remember everything. So all efficiency oriented parameters, speed, accuracy, long time storage, and etc. Okay, repetitive mechanical task and etc. Computer is really very, very good. And because of this, and with the help of stored program concepts, we are having a lot of application of computer in many fields. Computer application has become ubiquitous. Everywhere it will be applied, whether it is a bank, whether it is a railway, whether it is education, whether it is any type of, you can say, rocket science, starting from regular activity to the spectacular activity, we are having applications of computers, particularly digital computers. This is the internal block diagram or logical block diagram of a computer. Okay, whatever you give to computer, whatever data and instructions you give it to computer, and accordingly it will be processed by a computer, and then accordingly output will be given to you. So what is there inside in the computer? So there is a central processing unit. You can see the monitor, you can see the keyboard, mouse, and etc. And in between, whatever box you can see, that is a CPU box. Inside, there is a CPU. But the box is not the CPU. That you should remember. Whenever desktop or a laptop, you can see laptop, there are no different divisions or different, you can say, compartment or a standalone instruments or devices. But in desktop, if you have seen a tabletop computer, you can see at least a monitor, keyboard, and a mouse. So keyboard and mouse are the input devices. Monitor is the output devices. And in between, whatever you enter from a keyboard and then output will be there on a monitor, it will be processed in between. So between input and output, there is a processing. And this processing is done by CPU. Many people misunderstood that the box, black box or a white box which is available with your monitor and keyboard, that is the CPU. CPU is just a chip based processor. It is a processor based on a single chip. Nowadays, we are having a silicon chip. Silicon chip, we are having a processor. So central processing unit is there, and then within that central processing unit, we are having some control units. We are having some, you can say, circuits, rather I should say, that units that actually does the arithmetic and logical comparison, arithmetic calculation and logical comparisons. And there are a variety of memory. Some memories we are providing from outside, some memories are there on the, you can say, board itself, or you can say within the computer itself, internal, external, you can say primary, secondary, or auxiliary, you can say, and different types of memory. Later we will see what type of memories are there. So this is the logical procedure in a previous slide. It takes data, it remembers and executes and processes the data, and it outputs. So this is a typical working. Inside the block diagram, what you can say inside this, the logical block diagram is like this. In between input and output, we are having a central processing unit. And central processing unit consists of three parts. The control unit, ALU, full form of ALU is arithmetic, and logic unit, and then we are having the memory unit. This is another representation of the same simple digital computer. We have control unit, we have ALU, but instead of memory, we have divided memory into two different sections. One is register. Register is nothing but high-speed memory. And then there is a main memory which you call RAM, random access memory. And then there is a disk, there is a secondary memory, you can say hard disk or any flash memory or outside memory, etc. And then there are input-output devices such as mouse, keyboard, monitor, projector, and joysticks and touch screen and the biometric and iris and whatever, printer, projector, plotter. And bus is nothing but a connection or a wire through which the data can move, data and instruction can move. So these are variety of representations. So if you write this, it is okay. If you have another one, this is okay. So this is another representation we have taken from different books. In the end of the slide, I have mentioned all the references: control unit, ALU, registers, primary, secondary storage, and etc. If you open a computer, you can see like this. So this is your CPU chip. Right side, bottom corner, you can see this is the CPU chip. Then you can have a main memory here. This is the main memory. Different type of enhancement slots, expansion slots. These are the ports through which you can have a virtual connection points. This is the hard disk drive, power supply, and this is the system board on which all these things are placed, mounted. Now, what type of computers are there? So microcomputers, mini computers, mainframe computers, supercomputer, and then there are different type of complete workstations. Okay, let us see what is the typical computer. Okay, microcomputer, typical microcomputer, the smallest in a size and the processing. Okay, that is called micro. And there is a biggest one which is called the mainframe. The bigger computer capable of handling the data processing such as a full bank and etc. but limited to this. Then there is a mini computer, medium-sized computer. So based on two parameters, number one, the size, and number two, the processing power, we are having micro, mini, and mainframe type of computers. And for them, we are having different types of operating systems and different type of software. Then we are having the ultimate, the fastest computer capable of handling 100 to 900 MIPS, million instructions per second. MIPS is also a full form that you should remember. When it comes to supercomputer, the speed is measured in terms of the handling the transactions, instructions. So 100 to 900 million instruction per just 1 second. So when just you say just a Mississippi or 1 second, at that time it can handle 900 million instructions. Because of this only, it is known as supercomputer. But the workstations are more robust than a simple desktop and a laptop with enhanced specification. Faster CPU, not that much like supercomputer, or it depends what type of workstation you would like to configure. So it can have any of these type of computing facilities with added enhanced rather computing and processing power. So stand-alone workstation, independent workstations are also there. It can have a combination of variety of input, output, and processing devices. Then basis on data handling, what type of data it can handle, we can divide the computers into different categories. Okay. So first is analog computer, the second is digital computer, third one is hybrid computer. Analog computer nowadays are of less use, and digital and hybrid computer. Digital computers are rather most useful and more highly used in all the domains. For example, digital, as we have just discussed before 10-15 minutes, digital computers are called digital because they are capable to handle a digit, you can say, or you can say all the data and instructions in a binary digital language, zeros and one language. So that is why it is called a digital computer. But sometimes we have to process signals, like a temperature, analog signals. So for that, we are in a need of analog computer. Nowadays, most of the computers are digital, though use of IoT and other devices are increasing. Like we are having a sensor to measure temperature. So that data we need to convert it into the digital, and then accordingly we have to operate it. So that is why sometimes we are in need of a hybrid computer. But most 99% we are utilizing digital computer in a typical scenario. In a special scenario, we would be using special projects, we would be using research and etc. We would be using hybrid computer. This is the picture of analog computer. So there are three types of a computer category: analog, digital, and hybrid. And within a digital, you can have a micro, mini, mainframe, supercomputer, and then workstations. Let us talk about the memory units. So as we said that we are mostly talking about the digital computer. In a digital computer, we are utilizing binary language to store data and information. So the basic unit of information in a computer, because computer has got a memory. Now, what is the task of a memory? It remembers a state. Okay. So there is a unit in a, you can say, computer, or a circuit in a computer, basically flip-flop. Circuit in a computer that remains in a state unless we give another data, or we provide the change in the status, or we request for a change in the status. So it is a kind of a circuit. We call it a memory unit, and the memory unit is nothing but called as a bit. Single bit. 0 is a bit, 1 is a bit, and 0 represents off and 1 represents say. Okay. For example, it represents 1. 1 represents on, 0 represents off. So there is a single bit. Again, I am telling that memory is a circuit actually, and it remembers a status. And if it is on, the status is on or alive, true, 1, then it is, you can say, considered as on, and otherwise it is off. Okay. High, low, on, off, true, false, 0, 1, etc. are the possible values of bit. Okay, whenever you are working with this bit. Now, with a single bit, what you can remember? Yes or no, true or false, okay, white and black. So this type of data we can remember. Only 1 bit memory contains only 2 types of information. Either high or low, either on or off, true or false. But in a computer, if you remember, we can have full films, full albums. You can have a movie You can have so many things in a computer. Whatever amount of memory you have in your mobile and a pen drive and in your computer, you are always in a need of more and more memory. So many things you would be storing in a different format. So one bit is obviously not sufficient. You have to have many, many bits. So that is why we are having a group of bits, and we are having different names to it, nomenclatures for this group. So group of the 4 bit is called a nibble, Ni or Ny, nibble. Bytes consisting of, normally we are talking in terms of byte, not a bit. Byte is a group of 8 bits. So for our count, we can say ease of use, we are grouping the bits into normally byte. It is a popular one, and whatever other things are there, we are measuring in terms of byte, not a bit. So a bit is a single unit of a memory. Nibble contains 4 bits. It is a group of 4 bits, and a byte is a group of 8 bits. So a nibble consisting of a byte consisting of 2 nibbles. And then there is a word. Different computers are having different word size, but 32 and 64 bits are common. Earlier it was 16 also, but nowadays 32 and 64 bits together makes a complete word. Like in a Gujarati and Hindi, we are calling it akshar and shabda. We are having a bit as a akshar, and the word is a complete shabda. Say, when you are talking about 1 bit, now people are talking about kilobyte and megabyte and gigabyte and etc. So these type of conversion question might come in your NET examination. What is memory? How computer stores information? And what is how many bytes will be there in a nibble? Okay, half. Okay, and how many nibbles are there in a byte, etc. etc. So 1 bit is equal to 1/8 byte. 1 nibble is equal to 4 bits or a half byte. 1 byte is equal to 8 bits and 1 byte. Okay. Kilobyte, then we are having 2 raised to something. 2 raised to 0, that is 1 bit, 1. Okay. Then 2 raised to 10, that is a 1024 kilobytes, not 1,001. Normally, when we are talking about a liter or a kilo and etc., we are having 1,000, that word come into our mind. But in case of binary language, it is 2 raised to 10, 2 raised to 0, 2 raised to 1, okay, 1 byte. 2 raised to 1 is 1 byte, 2 raised to 0 is 1, 2 raised to 1 is 2, 2 raised to 10 is 1024, then there is a megabyte. Previous you have to remember, 1 megabyte is equal to 2 raised to 10 or 1024. 1024 is a magic number, you should remember. 1 megabyte is equal to 1024 previous one, kilobyte. Similarly, gigabyte, terabyte, petabyte, exabyte, zettabyte, yottabyte, and so many things. So this much size you can consider for a yottabyte. You need not have to remember this one. Just you remember this, how many. This sequence, if you remember, then it is easy for you. Then comes hierarchy of memory. When we are talking about memory and we know how to measure the memory in terms of bit, byte, nibble, kilobyte, terabyte, and etc., then how much important they are and how they are actually having their place in their hierarchy. Which memory is important and what type of memory, which memory is faster, which memory is costlier, and etc. So the base is the sequential tapes and optical discs. They are the normally cheapest and the most useful, but the slowest one, and their access mechanism is also different. Then comes the magnetic disc, faster than this. Then comes the main memory, rather faster than this. And then cache memory, the memory within a high-speed memory, within a computer itself. And then registers, within the CLU, we are having a high-speed memory, that is a register. So cache, sometimes it is there, registers are there. These are high-speed, small size, costly, and faster memory. Whenever you are just coming up to the triangle, the size is decreasing, cost is increasing, the processing speed is also increasing. So the cost and processing speed both are increasing when you go up. Magnetic tape, optical disc, and magnetic disc, and main memory, dynamic RAMs, static RAMs, and then CPU registers inside this. When you go up, you can increase in cost. When you go down, the capacity and access time is increasing. When you go up, access time is decreasing very fast, so time is decreasing. People are talking about primary memory, secondary memory, auxiliary memory. So let us consider, let us clarify our concepts. Okay, what is primary memory and what is secondary memory? So the primary memory, which is also known as main memory, is an important part of computer in which data are stored for quick access. Just like when you are traveling, something you are keeping in your pocket, like your passport or your purse, hand baggage. So that is your primary memory. But when you are putting something in your suitcase and then you have booked your luggage, that is your secondary or auxiliary memory. Right now, it is not available when you are traveling. It will be available after some times or through some procedure. It takes some times, it takes to follow some procedure, then only it will be available. But primary memory is just things are there in your pocket. You can just put your hand in your pocket and access it. So that is why quick access is possible. It is the main memory. And why such a main memory is required? Say, I have said that ours is a stored program concept and the program is actually stored into the computer memory. Maybe in a pen drive, maybe in a disk, maybe in a magnetic tape and etc. Somewhere else, maybe in a cloud somewhere. We have to download it and then we have to use it. Whenever we would like to execute a program, the program has to be brought into the main memory and then only line by line the program will be executed. So main memory, if it is bigger one and good quality, then it is good for you and quick access, quick execution is there. But all the programs which you would like to execute cannot be put in a main memory always because it is costly also and we have limited spaces also. So we cannot put we cannot have good amount of main memory. We have a reasonable amount of main memory. And if you go, it is costly also. So if you go on increasing the slots of main memory, it will be costly for you. So your processing will be fast, but we don't have to worry about the faster processing. Otherwise also the computer is much more faster than human being. So it is okay with us if it is taking some more nanoseconds, it is fine with us. So primary memory, faster one, very speedy, providing quick access, also known as main memory, and made of larger number of cells. And how an item is called from main memory, the memory cell is having an address. So suppose I define I is equal to 10 in our computer. Total number of work days in a week is equal to 6 in a computer. So week days is a variable which is containing an address of a memory cell. And whenever I call to use this weekdays, 7 or 6 value will be taken from that memory address. So it is kind of a house address number, and from that number we can access a person there. So memory and byte, bit, etc. cell, okay, where you are putting your items, we are putting your information, data, and instruction. These would be identified by a unique address. Okay. And each cell contains a piece of data. Whenever you require to access data, you should know the address. Okay. Otherwise, you cannot use the data. Okay. Now, primary memory is also known as random access memory, RAM. Okay. So, why it is called random access memory? Consider you all 12 to 15 people, 20 people are sitting in a class, and I would like to call you randomly, not according to your names, not according to your marks, not according to your roll numbers. I don't want to call you one by one according to your exam number or roll number. Okay, number 1 would come first, number 2, second would come then number 3, number 4, number 5, not like that. I would like to call a person or a student randomly, number 17, number 13, number 12, like that. That means time taken to access the first element, last element, or any element is same for all elements. I can access the 17th element at the same time. I can access the 7th element at the same time. I can access the first element at the same time. I just have to point out, I know the address and I can call that person. Okay. 7 number is sitting on a bench number 3, 8 number is sitting on a bench number 9, and 17 number is sitting on a bench number 20. That's directly I will be calling because of address. So randomly I can access an element. That is why it is called random access. In case of other memory, we are actually we have to go sequentially. Suppose it is stored in a secondary memory on a magnetic tape, like in the good old days, your grandparents or parents would have used this thing. Mainly grandparents might have used the audio cassettes. So you have to pass the 5 songs are there, and if you would like to hear the fifth song, you have to fast forward the 4 songs first, and then you can go to 5 songs. So if you are calling roll number wise, you know the address of one only, you can go to one and ask where is second. Then you can go to second and ask where is third. Then you can go to third and ask where is fourth one. And then you can call the fifth number. That is a secondary memory. In case of the random access memory, we can randomly access data. So time required to store or retrieve data from a cell is independent of the other cells and directly depending on the independent from the cell. Directly we can access it. So that is why it is called random access memory, primary memory, main memory, quick access memory, high speed memory, etc. RAM, etc., etc. are the synonyms. We are utilizing these synonyms. There are other methods, as I stated. That is a first in, first out FIFO method, and the last in, last out, the LIFO method. Last in, first out, LIFO method. In a sequential access, data is stored in a sequence in a serial manner only in a long string. So if you want to access the some part of the strings or middle data, you have to go through the first initial data and then only you can go to the data like audio data. And then a FIFO, first in, first out, okay. It is like a queue at a petrol pump. You go first, you will be served first. But in case of stack, okay, it is like a tray or a pile of papers. The paper which you have put first, it will come last. The paper which you have put last, it will come first. So this is the first in, first out. You are going inside, system process, and you will come out in the same order. And this is a last in, first out. You are going here and then come. This is the way how picture of a main memory. How does it look? Okay, the RAM is a volatile. Now that is a new word coming to us, volatile memory. What do we mean by volatile memory? Volatile memory means it will not preserve its content. The circuit will be not in a same position or a same state where you have entered, or it will not remember its status. So that means whenever you are having the power fluctuation in the power supply, it resets everything. Okay, so the content written in this random access memory requires continuous power supply. Otherwise, the information written into it or its status will not retain by it. So it requires continuous power supply. So we require UPS or we require generator and etc. etc. But the power supply must be continuous. Again, there are types of RAMs. 2 basic types of RAM are there. Many types are there, but 2 basic types are there. One is static, another is dynamic. But when it's dynamic means it's continuously changing. We are normally talking to people, you are a very, very dynamic person. That means you are adapting situation in a very fast manner. And you can adjust somewhere else. You can adapt many new technologies and you can fit in this and that and different type of situations. So you are a dynamic person. Similarly, dynamic RAM that needs to be refreshed thousands times per second. We require continuous power supply. That is one thing. The second thing is that the dynamic RAM continuously needs to be refreshed 1,000 times in a second. Another way, the static RAM does not require to be refreshed. Once it is stored, some item is stored in it, it will be there till there is a continuous power supply. Since it is not refreshing 1,000 times per second, it will save a lot of time and hence it is becoming faster. But it is much more expensive than that of the dynamic. So static RAMs are much more expensive. Both the type of RAMs, RAM is random access memory, number one. Time taken to access any element is same whether it is the first element, whether it is a middle element, whether it is the last element. It is a quick and high-speed memory. It is costly also, and it requires continuous power supply. There are two types of RAM, dynamic and static RAM, but both the RAMs are volatile. Dynamic RAM means needs to be changed, needs to be refreshed 1,000 times per second, but static RAM is much more faster because it is not giving its effort and wasting time in refreshing itself. So static RAM is very much faster. Then there are another type of RAM, ECC RAM. Nowadays it is becoming very popular, automatic error correcting type of things. So it is ability of RAM to detect mistakes while communicating data, and you can say refresh itself or gives some, you can say, error correcting facility. So this is ECC RAM. ECC RAM nowadays is becoming popular. Earlier it was not there. Then there is another type of memory which computer uses, that is the read-only memory. Say how to boot your computers. Some basic things while you are starting computer. Every time we need not have to run the program. We just have to start the computer, switch on the computer, and automatically some programs must be, you can say, executed automatically when you switch on the computer. Every time we are not changing it. So those things we can write in a permanent memory. Only read. These are the memory which can be written once only and read many times. So, and then there is a variation in it also, but basically it is a read-only memory. We cannot write to it without a specific thing. Specific, you can say, mechanisms and means. We can write it into read-only memory. Now, once we have to write in that memory, if we are not able to write into the memory, it is totally useless. So at least once we have to write in memory, but many times, once you write and many times you can utilize this memory for some standard purpose. So to permanently record data and instructions like booting the system, starting the computer systems and etc. The printer setting file. Printer setting files are also keep on changing, but booting the systems is the classical example where we need to write something permanently, and that is there in the ROM, read-only memory. The content of ROM can only be read. Normally, we are not writing on it. Unlike RAM, ROM retains its contents because it is permanent. So even though light is on or off or fluctuation is there, okay, ROM retains its contents. RAM will not retain its contents. Okay. ROM is an ideal, read-only memory is ideal to store critical instructions such as booting programs, programs that start up computers, printers, writer files, fonts, etc. Variation of a ROM, and there are variation, like we are having many type of random access memory, read-only memory also we are having many types further. So programmable read-only memory, PROMs, okay. For that, it's a specific type of, you can say, read-only memory which you can program yourself. So it's a specific device you require to write the data. So erasable also. Once you have written a data and then you would like to erase it, you can erase it also. So erasable PROM, erasable programmable read-only memory. Full form you should remember. Erasable programmable read-only memory. And ultraviolet light it can be used, or otherwise electric erasable probe can be there. Either with the, typically with the ultraviolet light or otherwise with the electric signal, you can erase the content in the programmable ROM and then you can write a new program. And you may be having actually, you may wonder why we are using this erasable PROM and this, but regular basis we are utilizing, say, flash drive, USB pen and memory card and etc. These are example of electrically erasable PROM, the EEPROMs. They are very, very useful, but having, you can say, less life. You cannot depend on your pen drive for long-term storage. Cellular phone, memory card, USB drives, and etc. They are erasable PROM, electrically erasable PROM. So this is the picture of RAM and ROM. So what is the difference between RAM and ROM? RAM, random access memory, and ROM stands for read-only memory. RAM supports reading and writing operations into the computer in a normal way, but typically ROM is a read-only memory, and even though you are having programmable ROM and electrically erasable type of ROM and etc., we can treat it as a secondary memory and we can utilize it as a flash memory once or a while we are writing it and many times reading. But inside computer, there is ROM available, that is a read-only memory strictly. Okay. So in case of RAM, we are having static RAM, dynamic RAM. In case of ROM, we are having PROM, then EPROM and double EPROM. So these are the variations. And data and instructions stored into the RAM and instructions are stored during the manufacturing or once you would like to use RAM. RAM, major difference of RAM and ROM. The RAM is random access and that is read-only memory. And RAM is volatile one, ROM is non-volatile. Then comes second, these were the primary memories. Now we are coming to the secondary memory. Some type of ROMs can be treated as a secondary memory, like the flash drives and USB drives. But the hard drives, you can see the picture of hard drive. This is the hard drive. Then we are having solid state drive, okay, SSD. Then we are having optical discs, magnetic tapes, and so many secondary memory storage devices. It is called storage devices. So these type of storage devices are making drums and discs and tapes and etc. Nowadays we are not using this, okay, but we are using the EEPROM like pen drive and then CD drive and solid state drive and hard disk. There are two types of hard disk actually we are familiar with. One is inside our CPU box and one is the external hard disk. Just like a USB pen drive, you can insert with the USB cable to your computer. And you can utilize it like a flash drive. Then some simple things are there like popular input devices. So keyboard we are familiar with. Then mouse we are familiar with. Then scanner. There are multifunctional printer available which can scan, which can take a photocopy and which can print. And inside there is a queue managed by the printer driver file. Whatever command we are giving, it is going to a queue. A printer can be attached in a network also. If there is only one printer and 2-3 laptop and computers available in office, we can make them or connect them into a network, and later on we are having all these computers can be utilizing same printer. It may be possible my computer is here in my office, but my printer is on the other floor laboratory. I can give command here. If both the computers are connected, I can share the resources. Later on, we will see how we can share it and what is the computer network, etc. Introduction I will do. So keyboard, mouse, scanner. You can see mouse here. Then this is the biometric fingerprint scanner. This is a typical keyboard. Then this is the iris scanner. I did a project with, you can say, Russian people. I took an Indo-Russian project from DST, and we have developed a mobile-based domestic application using this type of scanners. This is a handheld scanner. You can hold it in your hand and you can scan it. This is the reader, okay, OCMR and other type of reader. This is a joysticks. This is the face recognition. This is the light pen. So these are all input devices. And another important input device nowadays, little bit costly, and this is the Pranav Mistri's gesture-based technology. Normally, when we are taking say cricket and etc. So when we say 4 is like this, 6 is like this, and whenever the guests are coming, we say this namaste to you. Even though we will not speak anything, but we through our gestures, sometimes smile, sometimes bowing, sometimes just joining hands and etc. So this is the gesture-based technology, and a pendant intelligent version of this gesture-based technology is in the market. So if you just pinch like that, the system will be, the photograph or the screen will be increased, the pinching operation. You can resize it, you can increase it, and etc. So based on, you can wipe screen and clear screen like this. So these are the gesture-based input. So your gesture, your facial expressions, your voice, okay, your inputs like the commands to keyboard, your clicks of the mouse, okay? Your, you can say, pen, tip of your pen, light pen, these are your iris impression, your face then itself. These are the possible inputs, and to consider these inputs, we are having a variety of devices. These are called input devices. Similarly, we are having output devices. We are having speakers, monitors, projectors, and printers, Bluetooth and hands-free, and then there is a speakers, okay? Alexa and etc. type of speakers. Computer memory we have already seen. This is just revisiting the computer memory. Two types of computer memory basically. One is primary memory, another is a secondary memory. And we have random access memory, quick, fast access, volatile, containing static RAM, dynamic RAM. Dynamic RAM will be actually considered refreshing itself 1,000 times in a second, but it slows this speed. SRAM is costlier, faster, will not actually refreshing itself. And the complete RAM, all you can say this, will not retain its status when there is a power fluctuation. It is volatile type of memory. But in case of ROM, it is a read-only memory. Once it is being manufactured, we are writing the content into it, and then many times, writing once and using many times. But even though we are in a part of your project or your applications are like that, you have to program it. So programmable ROMs are available, electric erasable programmable ROMs, and again you can write it, that is also available, and electrically erasable programmable ROM are also available. In case of secondary memory, we are having a CD-ROM, write once, okay, and then CD electrically erasable, or you can say programmable ROM is also available. So CD and then rewritable CD and etc. Flash memory, pen drives, a memory card, hard disk, etc. are secondary. So computer memory is nothing but a combination of the compilation of the group of bits. But the way how you can access it and how it works, it actually makes a primary memory and secondary. And bit, byte, and nibble, and kilobyte, terabyte, megabyte, etc. we have seen. So cache memory is a volatile type of RAM, volatile memory, and often access high speed, very near to, you can say, the CPU. Sometimes in the, you can say, CPU itself, like registers, and it's a volatile memory. And frequently used data we are keeping into the cache memory. Another thing, registers and flash memory and cache memory, RAM, ROM, etc. we have seen. But one thing we have not yet discussed, that is the virtual memory. Sometimes what happens, as I said, that your program has to be brought into the main memory and then it will be executed. So suppose I have written a program to calculate percentage of thousands of students. Thousands of students data are there in a file. I will download the file and file with the thousands of students, 6 subjects, marks are ready, number, name, marks, everything, course and etc. That is ready with me. The students are marks and details are ready with me, number one. Number two, the how to calculate percentage and print mark sheet, that is also ready with me. And that is written in a 0101. I have written it in a Java and etc. C++, Java, or Oracle, and all these type of programs, .NET, C#. A variety of tools I will use, and I have made this program ready, and I have asked my translator, computer compiler, to convert it into zeros and ones. So my binary programs of the student data and how to calculate the percentage and how to print the mark sheet, these two programs are ready. But when I have to execute this 1,000-line program, I have to put it into the main memory. I have to bring it into the main memory. And if I will bring the, you can say, big amount of a data file and a program file into main memory besides other programs like Windows and operating systems and other things if I have to run, but my RAM is very small. I have a small amount of low configuration computer and I do not have 1,000 spare line available to store those programs. Then how my program would be executed now? I have 10,000 lines of a big program. And that has to be bring to the main memory, brought to the main memory, and then later on it has to be executed one by one. So at that time, we are having a concept of virtual memory where we have only 10 lines available in a RAM, in a main memory, but program is of 1000 line. At a time, we are considering 10 lines. We are bringing 10 lines into the main memory, and we ask our CPU to execute these 10 lines. When it comes to 9th lines, we again invoke a thread and we ask our operating system to bring some more lines, line number 11 to 20 into this things. Like now, a child wants to eat 5 chapatis at a time, but mother can make only 2 chapatis at a time. So mother says that, beta, you start eating these 2 chapatis. When you are going to finish the second one, 2 more would be in a line. Again, you finish the 4th one, then 1 more would be in a line. So child is experiencing non-interrupted supply of the chapatis. So that is the virtual memory. So virtual memory can be implemented with the help of the paging concepts. So this is the page size, and those page size can be instructions can be loaded into the memory. Then comes to the type of software. We are having very little time, so I am giving introduction only so that later on we can explore the topic according to your choice. We are having computer hardware. Here memory is also hardware. So we are having a computer input device and output device and registers and circuits, and whatever we have seen is hardware. So we have completed this inner circle, introduction of inner circle. Okay, what is computer and how it is working, and what you see, what type of boards and ports and enhancements and expansions are there, and what type of circuits are there, that we have seen. Memories are there. We have seen that is a hardware. So the things which you can touch, that is a hardware. But then later on, there is the instructions also. How to utilize this hardware. So there are 3 types of software, at least 2 types of software, system software and then application software. The system software, that means enable us to utilize this hardware regardless of your application, whether you belong to bank, whether you belong to railway, whether you belong to Supreme Court, or whether you belong to educational institute. You don't worry, you have to use computer, but you facilitate the utilization of your computer hardware, devices, memory, and etc. So that is called a system software. An operating system is an example of a system software. These are the utilities actually. So operating system is a kind of a system software which enable us to utilize this hardware. And you have to have a hardware surrounding at least one operating system, and then you can have your browser and games and databases and your application of library systems and your business ERPs and attendance systems. Whatever application software you want, you can put. So your hardware surrounding a system software, mainly operating systems, and then outer circle you are having all your application software. So this is the hierarchy of various types of software. Then comes an important topic of number systems. To express number, so far we are utilizing decimal number systems. So base is 10 and we are having a place value. The last one, the rightmost number, is actually having the lowest value. So suppose 121 is the number, the last one, or 123 is the number. The 3 number is having value 3. Then second number 1, 2, 3. Second number is 2. It is having a value of 20. And the third number, leftmost one, 3-digit number 1, 2, 3. Leftmost digit 1 is having value 100. So 1, 2, 3, 123 is actually 100, then 20 and 3. So every number according to its position has a value, place value. And we have in a decimal number systems, deca means 10. So in a decimal number systems, we are having 10 different symbols. But 10 is not a symbol in a decimal number. This is a tricky question. So 10 is not a number in a, not a symbol in a decimal number systems. In a decimal number systems, there are 10 symbols available, 10 numbers available, and these symbols are 0 to 9. Including 0, other 9 things are there. So total 10 different items are there. Excuse me. Total 10 items, 10 symbols are there, and using these 10 different symbols, like in alphabets, we are having 26 alphabets in English. In China, we may have 300 to 400 alphabets. I don't know in Mandarin language. So that way in a decimal number system, to express a number, we are having 10 symbols, 0 to 9, and we can represent very bigger. Number system, number line is infinite, minus to plus. So using these 10 numbers, we can have infinite number can be represented. In case of binary number systems, like its name, binary has got only two. Binary means only two. And binary number system has got two symbols, 0 and 1. 2 is not there in a binary. Number 2 can be represented with the help of binary symbol 1 and 0. Similarly, octa means 8, and we are having 8 symbols in a octal number systems, 0 to 7. And hexadecimal, hexa means 16. We have 0 to 50. Now only one place is available, one symbol is required. So for up to 0 to 9, it is okay. But when it comes to 10, we are utilizing A. When it comes to 11, we are utilizing B. So A, B, C, D, E, etc. we are utilizing for remaining numbers. But we need to remember that decimal means deca and deca means 10. And decimal number systems, we are using 10 symbols, but 10 number is not available. Symbol is not available in number system, decimal number system. Similarly, binary contains two symbols, 0 and 1. 2 is not available. 2 symbol is not available in a binary number system. And in octal, we do not have 8. And in hexadecimal, we do not have 60. So, and it is not that only decimal, binary, octal, hexadecimal, only these systems. The binary number system is having base 2, two symbols 0 and 1. The decimal number systems are having base 10, 0, 9. So 10 raised to 0, last digit is having 10 raised to 0 means 1 multiplied by 1. Last but one digit is having 10 raised to 1, 2 into 10, 20, like that. Okay, so base is 10 for decimal. Binary base is 2, octal base is 8, hexadecimal base is 16, 0 to 9 symbol and A and F. So that way we are having number systems symbols. And conversion within one another is possible. That is one thing. Second thing is that with the base 6, I would like to create my own, for example, 5 or 6, if I would like to create my own number systems, or I would like to utilize a specific number systems with base 5 and base 6, I can do that. How to convert a decimal number into binary? Just a hint I would like to give here. We cannot take this practice because of time limitation. But suppose 243. So 3 into 10 raised to 1, 10 raised to 0. Then 4 is 3 plus 40 plus 200. This is the way how this number has formed in a decimal. Now this number I would like to convert into binary. So go on dividing by 2. So 2, when you divide 243 by 2, you would be having 121. And the remainder is 1. Because this is an odd number, the remainder is 1. Again, this result, again you go on dividing by 2, the remainder is 1 because 121 is an odd number. Then it comes 60. Okay. So 60 is an even number. When you divide by 2, 30 will come and the remainder is 0. Like that, whatever reminders are coming in a reverse way, you are writing 1111 0011. This is the binary equivalent of 243. Similarly, decimal to octal conversion. Same 243 number, you would like to convert it into the octal. Go on dividing by 8 till you are having a final remainder, which cannot be further divisible by 8. So 363, that is the octal representation of the decimal number 243. So 243, if 10 is written, it is having a different meaning. 243, if 8 is written, it is a different. Say 363, if it is a 10 here, decimal value, decimal number system, then it is a 300 plus 60 plus 3. But here it is a 383, that means 3 multiplied by 8 raised to 0, 6 multiplied by 8 raised to 1, and 3 multiplied by 8 raised to 2. decimal to hexadecimal conversion. Divide by 53. So we have 153. Here the remainder is 15, which cannot be further divisible by 16. So here 15 is one symbol and 3 is another. So F3 is the hexadecimal conversion. A reverse way. The same number, 111, now this is another number, 1110101, how it can be converted into the decimal. So we'll start with the last one, this one. Right side, last number 1 with the base raised to 0. We'll start with a 0. So 0, 1, 2, 3, 4, 5, 6, 7. Total 7 digits are there. So 2 raised to 0 multiplied by this digit, 2 raised to 1 multiplied by this digit, plus 2 raised to 2 multiplied by this digit. That way you can go on, continue, and then do the summation, and it will be converted into 10. Then comes a new topic, computer networks. What is computer network? So computer network is actually practice of connecting networks, connecting computers, so that the communication between this network, this computer is possible, number one, and they can share their data and other resources, including printer, including memory. Your cloud is a computer network. Later on, we will discuss something about cloud also. But we are having the computers connected with each other. How it can be connected? So there are some medias available, wires available, coaxial cable, optical fiber, sometimes wireless also. Okay, so that way we are having different type of connections. There are computer connection devices also, the wire, switch, hub, connector, and etc. And we are connecting in some format. Why computer network is necessary? Because we want to share some data with each other. I do not have computer, but if I connect my computer into a network which is having a printer, so I can print it. I do not have data, so let me connect it. I do not have an operating system. I do not have some software, so let me connect it. And then some data we are available, we can take it from other computers. Mainly some facilitated computer is available, which is having lot of resources. It is called server, and other are client. The basic terminology of computer networks. Network is a collection of computers, not only computers, but devices are there. Basic purpose is to share the resources, data exchange, and communication. What is called a computer attached into a network? It is called a node. So nodes are nothing but the computers or devices that are connected to a network. When these are connected with each other and they start always talking with each other, there should be some protocol, there should be some standard. And like guests are coming at home, we are actually welcoming with the namaste. Now it is not compulsory to say Jai Hind and Namaste and good morning or Jai Shri Krishna type of things. But we would be doing it is a protocol, it is a sanskar, or it is actually a kind of a standard we are. So set of rules and standards which are not mandatory. Without that also, we can welcome the guest. But if these rules are there, there is some control, there is some disciplined way, and it is the age of transmitting and communication and sharing. So that is why some protocols are needed. Protocols were never compulsory, but it facilitates a lot. It actually helps a lot, and it helps an easy and smooth communication between the. Say when computers are connected in computer and all are talking at a time, then all are asking for the same type of resources. All are going somewhere else and sharing something or asking for same type of data. Better we should have some sort of discipline there. So some set of rules and standards are there. Better to follow at least some of them. Okay? Topology. What do we mean by topology? So physical or logical arrangement of a computer's nodes in a network. These are the example of the topologies. point to point, peer to peer, you can say. Then bus in a line, we are connecting computers. In a circular fashion, we can connect the computers. Then in a star, we can connect the computer in a tree format, one and then two, three, and then further you can say each is divided into many, that way tree format there. In FSR manner, in a mesh format, one is connected with another, another is connected with this. Okay? That is also possible. And you can combine any of this technology also. So that is also the possible topologies or arrangement, how we can connect the computers into the groups. How they would be communicating with each other. So computers, when they are communicating, they can communicate in a simplex way, half duplex way, and duplex way. Let us see. When information is sent from one computer to another computer, one computer can become sender and another will become receiver. And through a medium, maybe wireless, maybe you can say with the optical fiber, maybe coaxial cable or any type of medium, they are communicating information from sender to receiver. So this is a typical communication. Now, there is a simplex mode. It is a transmission mode when one device will become a sender, another will become receiver. One way only, like a radio broadcasting. When a radio telecasting is there, our Sardar Patel University has a radio station and we have our channel also 90.4 FM. So we are having a radio station when we are broadcasting something. One person, radio station particularly, from radio station we are broadcasting something. One or more station can be receiving only. Only one is sender, one or more will be receiving. Television broadcasting, radio broadcasting, computer to printer. Printer will not send like something else except some acknowledgement. Monitor output, fire alarm systems. We cannot interact with it. Only one way. Loudspeaker. Only person with the access of a mic and loudspeaker would speak. Other one or many people, many you can say receivers will receive this thing. So one way unidirectional communication is known as the simplex mode. Now there is a half duplex mode. In a half duplex mode, it is like actually in a polite telephone communication. When or in a classroom communication, classroom communication is should be a half duplex, but in a classroom nobody is asking question nowadays. Okay, the classroom discussion, walkie-talkie type of discussion, two-way radio, push to talk, and etc. Browsing internet, that is a half duplex communication. When device one is sending information, device two will receive and will not send anything. When device one is acting as a sender, device two will act as a receiver. When device two will act as a receiver, device sender, then device one is acting receiver. So when I am talking, you have to listen. When you are talking, I have to listen, like that. So in case of walkie-talkie, you must be watching some web series and thrillers in a OTT platform, Hotstar and Netflix and Amazon Prime, etc. So we are having a walkie-talkie operation there, Roger and etc. Over. When I say over, then you have to say copy and you can say start something and then I say copy over. So that way when you are talking, I have to listen. When I am talking, you have to listen. So that is a half duplex. Duplex means both the party can send and receive. That is why it is duplex, but in a half way. When you are talking, other party has to listen. And full duplex mode allows communicating devices to transfer information simultaneously. Okay, both are acting simultaneously as a receiver and audio calls and live chats. Suppose in a telephone call or in a, like you can say when two friends are meeting after a long time and they are overwhelmed and they both are talking, nobody is hearing. Okay, so in a video call, video conferencing, multiple people can talk. And we can have voices from many places, many participants. So that is full duplex type of communication. Then comes IP address, the unique number of every computer in the world. That is the unique number, numerical identifier to every device on a network. It can be a mobile, it can be a computer, it can be something else, but IP address and the range, the internet assigned numbers authority is there that is assigning this IP addresses from 0000 to 255, 255, 255, 255 IPv4 type of addresses. IPv6 is also there, version 6, and IPv4 is also there. So, 4 components are there in IP addresses. So, this type of question was there in the 2023, I think, so this IP address. Variety of, in UGC net also you can download the papers. And then there was a question regarding this IP address size. Which of the following is not a valid IP address? So there should be some 4 components, and within this range IPv4 particularly. Then comes DNS. That is a particular standard or a rule. Okay, it is a theory, it is a standard, it is a protocol that is actually converting the domain name. For example, ICICI.in, spuvvu.edu. Okay, so those type of domain names, timesofindia.org, for example. So those type of domain names into IPS. Okay. For our, you can say, facility, ease of use and etc. Say pritisadhya.com or pritisadhya.info, ICICI.india. Okay, so that way we are having some sort of domain names for a website. But this is the protocol, domain name system. That protocol actually converts this pritisadhya.com, ICICI.org into or Amazon.in into some IP addresses where that website is actually available. So you can download, you can load this website in your browser. So this is a DNS server. Then there is a firewall, security device. When your computer is connected with particularly internet or outside, you can say computers or servers and etc. devices, then you should have a firewall that actually having a control on incoming and outgoing network traffic. What is coming into your computer or particularly network, and that main computer, with that main computer, your other computers in your company, in your institutes are connected with. So that is the use of firewall. The security vault. Then types of computer network, LAN, WAN, and MAN. These are the 3 different types of computer networks. LAN is a local area network that covers a small area, such as office, home, etc. But in case of MAN, the last one, yes, please. In case of MAN, we are having a little bigger one, like a metropolitan area, typical city or town. We are having a metropolitan area network. Computers are connected throughout the town. In an office, if there are some printers and computers and other devices, if they are connected with each other, it is a LAN, because in the same building. But if there are campuses available of a university, for example, different buildings are there, and throughout the, you can say, town, university campuses are there, or say ICICI Bank branches are there, then you can have a metropolitan area network. And then there is a wide area network, the large geographical areas such as a complete city, regardless of business, not only bank or not only university, but all the things. Then country or entire world, like internet and etc. Internet is known as network of networks because we have different networks in our, you can say, company. And then this network is connected with the other network. So network of networks, that is called internet. So internet is a global network and we are having network of networks. Across the world, you can remember this blue color phrases only, nothing else. So it's a global network, and with, you can say, across the world, we are connecting computers and servers. And based on this internet and World Wide Web and cloud and etc., they are different things. Internet is actually a platform. Internet is actually a facility, or it is a network which actually facilitates the machine is connected with the machine. So worldwide machine we are considering, the machines available in the whole world we are considering, and these machines are connected with each other in a one or another way. That is called internet. Internet is a platform for worldwide. If machine and machines are connected, so with the help of some protocol, we are actually have open, you can say, a web page or a file or a document, and from that there is a hyperlink available. So hyperlink text control protocol. When we click on the hyperlink, suppose in my computer, there is a document here in a PowerPoint, and when I click here, it will go to Sardar Patel University website, my university website. So from one computer document, if you want to jump to the another computer document, okay, another website, then these computer must be connected with each other. So if you are having a platform of internet, then only you can have a world wide web, the web of documents. But it is only possible if you are having internet. So internet and world wide web. And people are talking about cloud also. So the cloud is nothing but somewhere in the cloud, say, in the layman's language, you are putting some resources. Sometimes you don't have operating system. Sometimes you don't have much more memory. Sometimes you don't have some programs and software available. Sometimes you don't have a platform available. So services and platform and OS and hardware and software and so many things not available. Borrow it from somebody. That is cloud. And like if you are using Apple and etc., you must be knowing this. The iNet and other type of software you have to download for songs. Suppose I would like to hear songs. Practical example I am giving. And while I am working in kitchen, I would like to hear songs. While I am walking in a gym or a park, okay, evening walk or morning walk I am taking, I would like to hear songs. So I have, and while working in a lunchtime also, I would like to enjoy songs. And in my home also, drawing room also, I would like to enjoy songs. Now, one song I like very much, and I have to copy it in my mobile. I have to copy it in my stereo or other tape recording or other devices. Then I have to copy it in my office also. Better, I will put that song in a cloud somewhere. Pune base or Baroda base or somewhere in Mumbai base server, somewhere in a cloud I will put. Consider it is in a clouds really, okay, in sky. That whatever devices I would be using, instead of copying 4 times, 5 times in my one mobile and another mobile and another device and computer and laptop everywhere, instead of physically downloading, I need to register and connect all these computers or machines and mobiles with that cloud and internet. So my song is available somewhere in the sky, and whatever devices I can attach with or log in with this, I can use the song, I can play from the cloud. I know I must have the connectivity, I must have the data, and I must have the good bandwidth. Then only I can these things. But storage of one only, so one time only, and utilization many times with multiple. Your Google Docs and etc. are there in the cloud. So regardless of the situation, you can use it. So cloud is literally outside, but you can have a nearer, you can say, to your intranet, internal network, that is called intranet. So your intranet also you are having a fog. Cloud is far away, but the fog is nearby. So fog computing and cloud computing are also becoming very, very popular. So worldwide web. And there are some devices which you must know, that is a modem. So when computer is connected with another computer, there may not be the complete, you can say, dedicated network, a wireless network or optical fiber network. Many a times we are using telephonic network because telephones were connected. But our telephone network works, unlike foreign countries, our telephone network works in analog signal. So we require a modulator and demodulator to modulate the digital signal into the analog one and the vice versa. So modulation and demodulation is required. What are the different ways to connect to the internet? So dial-up connection with the modem and etc. Then broadband connection, wireless connection, Wi-Fi connections. Then WiMAX was also there earlier popular. And then mobile phones, satellite, and integrated services. These are the different ways to connect to the internet. Most of us are using, all of us rather, using internet nowadays. So this is known to us. When we are talking about internet, when my computer is connected with the other computers in the world globally, we have to be really very much cautious and secure, or we have to have an eye on what we are doing. So we have to utilize or install the antivirus, which can take care of the malicious programs, malwares, and etc. And another thing is that we can generate the complex and unique passwords. Don't write your password in your book and then leave it somewhere else. Put it in a locker, put it at one particular place, or generate a Word file or Excel file where you are having all the passwords and protect it with the nice password. Then keep on updating. Put it locally here, don't put it in a cloud. Okay? Virtual private network can be used. Incognito mode or private browsing can be used. And then there is a hypertext control protocol, and then there is a HTTP, HTTPS. So secure HTTP you can use instead of going for only HTTP. Okay. And social media accounts like the Instagram, Twitter, and etc. You can make it private. Okay. Only your friends can see which you have allowed them. If you have allowed them, then only they can see. Autofill, don't do that. All GPS, location, etc. unnecessary, don't make it on. Make it off. Okay. Log out, don't close the window. This is right side, you can see this is the actually representation of a file. So internet, any type of data can come. The red means harmful data, green means required data. So this firewall can access based on the keywords and the content given to instructions given to it. It will identify, but it is not 100% sure, 100% perfect. Okay? But it tries to identify the malicious data, and only the correct one or the valid one will be allowed into your company's network. Update software, update cookies. Don't use public Wi-Fi like airport and bus station, railway stations. Never download files from the unknown sources. Then there is a dark web, deep web, and etc. In a cyberspace, so a virtual web and etc., we are having surface web. Let me show you this diagram first. So this is the screen, just a minute. This is the surface web, dark web, and deep web representation. The surface web is actually what you are using right now, the content, web content mining you are doing actually. But you are not considering the law, considering the history, considering the deeply hidden things into the web. For mining this deep web content and the dark web content, you require special type of search engine. Google will not work. Okay? So here, suppose my company, insurance company is there, and all insurance details, bank details, deposit details, medical details, and etc. that I am putting into deep web, so to allow restricted utilization and access only. And this Google and Instagram, Facebook, etc., YouTube particularly, anybody can anybody can access. So this is a surface web. And a deep web, legal documents of a company, private forums, research paper, non-indexed content, etc., that we are keeping here. And the dark web, as the name is dark, actually it is an extension of a deep web only, but it is an illegal trade or illegal records. If you want 1,000 username and password of the some good Infosys type of company, then they would be available. I don't know whether it's just an example. Okay, so this is a dark web. Now you can see this thing. So surface web is visible to everybody, and using a typical search engine, okay, that is available to everybody, and you can access the information using the typical search engine. In case of deep web and dark web, you are having different type of search engine like Tor and etc. And these are the legal one. Deep web is legal one, but dark web is invisible, illegal web. Cyber security is also a good topic. A set of standards and practices to protect the data, programs, application, network, and etc. But still, cyber attack is possible. There is a malware, harmful software. There is the phishing. If the program or the communication method convince you to open the message and download it, spoofing, fake caller ID, etc. Then Trojan, something nice is coming, but when you download, seems very innocent and etc. Okay, download this. This is an advertisement. To know more, click here. Okay, and to get this type of reward, click here. But side by side, if you are games particularly, okay, download free games. So when you are downloading free games side by side, some other you can say software which is in form of, you can say, within inside that Trojan horse. So inside this, embedded inside that particular game, that also downloaded, and it is continuously watching your transactions. So that is also very risky. Ransomware, your system is hacked, and whenever you try to access your computer, your machine, a message will come. Okay, your system is hacked, and you pay this much amount of money, then only your system will be accessible. Otherwise, you cannot access your systems. Consider ICICI Bank, such a system is hacked, and then all the information about the fixed deposit and monetary transactions and loan amount and etc. that will be actually NRI accounts that will be not accessible. I will say that, okay, I have paid my all the loans. I have deposited this much amount of money. So bank must have backup, number one. And that is why bank people and other insurance and etc. they are having a blockchain type of technology. They are actually having a division of, you can say, small blocks of operations. And if you change something here at first step, 10 steps, okay? So first step, if you are changing, then second, third, fourth, fifth onwards, they are not allowing. So to impart transparency and security, we are having a blockchain technology also. Password attacks, ransomware, Trojan things, Internet of Things attacks, sensors, and you can say IoT devices can also have additional, you can say, accessibility to the network. They can talk, the Internet of Things, when things and things can talk with each other. Not human beings are talking with computer, interacting with computer through Google. But now there is a IoT-based device can also talk with computer and can download something and can change something in configuration, etc. So Internet of Things attacks, drive-by download, unnecessary things you are downloading, and then denial of service attacks. Okay, entire device or operating systems can be shut down with the help of this overwhelming traffic. Okay, so these type of variety of attacks are there. So as we have discussed, to prevent such type of cyber attacks, we can update our software, firewall we can install, we can take regular backup of the data, we can encrypt the data, strong passwords we can use. Then there is an intranet, private network. This is right side cloud, that is internet, but then there is a firewall, and here there is an intranet. So internal network of a company, that is called intranet. Then there is a site, website. When we are talking about internet, we have to talk about the sites also. So different types of websites, static and dynamic. Static website, just simple presentation of information. You have to manually open the code and there is a change. Okay, for example, I have 10 books published and 231 publications, journal papers and etc. That is fixed. Now, whenever I publish my 11th book, I need to update myself, open the source and then change the content and then again save it and then I will upload it on the server again. So this process I have to do again and again. But consider the backside, I am having a database, and whenever I publish a paper, I change the database. My website will take data from the database, whatever the data is. So I have to just change my database, everything will be dynamic. So static and dynamic, that type of websites are there. Then comes the virtual reality. This is also a new technology. nowadays, and COVID has taught us so many things, okay, how online learning can be made possible. And there are some subjects where practicals are required, like chemistry and etc. So this is the example to know more about the chemical structure or carbon structure, molecular structure rather, of an item, of an object. We can use the virtual reality. So virtual reality means it's virtual. It is not existing in real, but we can experience it. Then comes augmented reality. On the physical world, we can have the virtual reality. So like from the book, we can copy which is the picture of heart, okay? And then we can see that how kidney is working, how heart is working, how kidneys are working like this. This is an example of the augmented reality. And this is suppose in Italy you are going and you don't know how to rent a bike or where you want to go to hotel, but which is the way to hotel. So this is the live telecast from live picture in your mobile. Okay, exactly you are in the place. So and then this is in your mobile, there is a picture. And in picture, it is giving you an arrow. If you want to go to hotel this way, if you want to rent a bike, go to this way. If you want money, go to ATM this way, right? So this is the augmented reality. And if still you want to interact with that, there is a mixed reality also. Holography is also there. Majority of the topics I would like to cover it. When we are talking about computers and we do not talk about artificial intelligence and chat GPT, it's not possible. Na? So ChatGPT is a AI content generator nowadays, and it is developed by OpenAI organization, and it is based on generative AI, generative pre-trained transformer. It is actually using neural network type of models, and it is coming under generative and creative AI. Generative AI is the standard word. This is the way how it is actually working. Suppose I give the word phrase, the cat jump over the. Now ChatGPT internally calculates what will be the next sentence or next word rather. So it generates one word at a time based on our question. So if I give this sentence, the cat jump over the, then it will identify fence. Many people have talked about fence. So 15% people they are giving fence. Cat jump over the fence. So next word would be fence. Then some people have also talked about table. So cat jump over the table. Cat jump over the mouse. 97% people are using cat jump over the mouse. But a few may have read the poetry, that famous poem, the cat jump over the moon. So only 5-6% people have used this. So that is why ChatGPT earlier version they're open to everybody because they want this type of database. Okay, what type of word people are using? Unless people use this ChatGPT, they would not have created this enriched database backend. So once many people would be using this data would be enriched, and many people they would be giving the next words, and based on this learning, it will generate that fence is the proper word. But when you say that no, I don't want to use fence, then it will be using table. That is why ChatGPT asks you whether you are happy with this content or regenerate. When we say regenerate, this probability will be recalculated and again it will be generated. So one word at a time, ChatGPT. Then comes the last topic for today, that is the file formats. The textual file formats like docs. You know, there is a difference between doc and docs. Earlier version of the MS Office, particularly MS Word, okay, to write word processing, use word processing, particularly Word, and we save the file, it will be having document. But nowadays, higher version, latest version of MS Word, we are having DOCX because backend it is using OpenXML format. OpenXML format. That is why it is using extensive markup language format, XML full form. Okay, that is also a format, okay, website format, or you can say ontology format. HTML, XML, etc. then DOCX, rich text format, portable document format, and etc. etc. WordPad format. Then image formats, JPG, PNG, GIF, HEF, TIF. When you write with a good publisher, they ask your file in a TIF. Okay. Then audio formats, AAC, MP3, wave format, etc. etc. Then video format, AMV, MPG, FLV, flash file, animation, AVI. Programming formats, we are having .c, depending on the programming language you are utilizing. If you have C program, .c, then Java, .java, Python, .py, JavaScript.js, that way. Then compressed file format, jar file, rar file, 7z, ISO, these are the compressed. Website, HTML, ASP, CSS, XML, XPS, these are the web pages format. And many formats keep coming, but these are the popular formats I have. And a few things, a few lines I would like to tell you about the artificial intelligence, machine learning, and deep learning. Artificial intelligence is a field of computer science with a basic objective is to make machine intelligent. But to make machine intelligent, we need to identify the variety of data, information, knowledge, etc. And then we have to identify the heuristics and procedural rules and etc. And we acquire the knowledge. We identify the expert, we acquire the knowledge, we put the knowledge into the knowledge base, and then we are having explanation, reasoning, inferencing, self-learning, and other type of capability, and we build expert system, generally knowledge-based systems. And then we make machine intelligent one, but it may not work that much. Lot many data available, and just like human baby, we are keeping the human baby in a nice environment. What we are giving to our babies? Nice school, nice water bag, nice school bag. And we say that maybe you learn yourself. Similarly, we are creating a model and we keep the model into a nice environment. We are providing thousands of data to the model and we just ask that baby model to learn itself. Machine automatically learns from the data without being specifically programmed. That is called machine learning. And features also we are manually identifying, but if it can be automatically identified, it will be a deep learning. So artificial intelligence is a broad set, and machine learning is a subset, and deep learning is a specific subset of a machine learning. But the data science is a science of data. In data science also, we are utilizing the models and we are training models, but something we are actually working with the probability and rough sets and entropy and chaos and other type of things also. So for data science, some of the things are, and AI, some of the things are common. And in data science, we are collecting data, procuring data, processing the data, and then we are using specific software. And particularly when we are talking about big data, we are collecting data, we are heterogeneous data from variety of sources we are collecting. We homogenize it, we process it, we find out the missing gaps and etc., fill the missing data. And then finally, we are having analytics on the data, business analytics or data analytics. And then we have visualization. So data acquisition, data analytics, and data visualization, these are the basic things in a data science. Normally, with those who are working in a data science, R will be a good language. Python also we are using. And for machine learning and artificial intelligence, deep learning, we are using Python programming. Last point for today, that is a digital initiative by the government. So Swayam is there. Swayam Padhe, Aage Badhe. Okay. Study webs of active learning for young aspiring minds. इस स्वयं का full form है. स्वयं का एक हिंदी word भी है. Swayam has got a Hindi meaning also, and the Swayam has got a full form also. It is written here. Study web of active learning for young aspiring minds. Then there is a Swayam Prabha educational channels, DTH, direct to home. National Digital Library of India, E-Yantra for embedded systems and robotics. single window access to e-content. Virtual lab, FOSSEE, okay. Spoken tutorial, National Academic Depository for all your certificates of 10th, 12th, etc. Plagiarism software. So these are the digital initiative taken care by the government. These are the references I have used. So here we have completed our discussion.
Yes, student participants, if you have any questions, you can put questions to Madam. Jaimin Joshi is here. Ma'am, can you name computer applications which can be useful for research purposes?
Yes, there are so many applications available, and particularly nowadays we are utilizing artificial intelligence. Just like now to search, first thing whenever you are starting research, now you are doing literature review. And to search something on the web, we are doing web content mining, surface mining, and for that normally we are using Google. But nowadays people are using Google Scholar. And now latest trend is that not Google Scholar, but beyond that, people are using Semantic Scholar. And using this Semantic Scholar, it will identify, this is available in a beta version only, but it will identify what to read from the article itself. It will not only identify the related literature review and articles and papers, but within the article also it will highlight the content. So you don't have to read the complete paper, only a few paragraphs you have to read. So Semantic Scholar, Decision Tree Maker, image to text and text to image type of conversion, so many tools available. AI based tools are also available.
Anyone else has any question? Srushti Dave, ma'am, we have heard about Quick Hill. So we can consider in which category?
It is just Quick Hill software, virus software, antivirus software.
Hmm. Anyone else? Yes. Khushi? Then Drashti?
Yes, sir. I have one question. Can you please elaborate about intranet and extranet?
Yes, yes. Say, when we are talking about computer network, we know that computers and devices are connected with each other. Now, if it is restricted to one company only, say my Sardar Patel University in computer science only, it is an intranet. Through intranet, I can connect to network also with in between a firewall. Sometimes I am utilizing an extranet also, say ICICI company, that is an intranet to them, but it is extranet for me. Some other companies intranet, it is extranet to me.
Anyone else? Don't question for the sake of questioning. If you have the real problem in whatever she said, then put the question. Okay. Yes, Khushi is there. Khushi is trying to say something. Yes, Khushi.
No, sir.
Okay. So thank you very much, madam. On behalf of the department, on behalf of my colleagues and student participants, I thank you for sharing your views about this topic. It's an easy topic for you. Probably I heard you about RCT in December.
Okay, sir.
Uh,
Yes, sir.
Yes. So thank you very much. And thank you very much, student participants, that you remain present. 28 are here, and how many?
Right now, the 13, but
13 on YouTube. So
Thank-
some 45 students took part. Thank you very much, madam.
Thank you
Thank
very
you.
much again for giving me the opportunity. Thank you, sir.
Thank you.
All the best to participants.
Uh-huh.